our very first episode of Applied Imperative. It's Applied CAx's new podcast. I'm Cheyenne Ng. I'm the marketing director here at Applied, and I am so happy to be joined here today with our host, Dale Goulding. Why don't you go ahead and introduce yourself, Dale?
Yeah, thanks, Cheyenne. Great to be here. We're starting a new podcast. I'm really excited for this. I have a too long probably, career in the industry now, mostly in aerospace. I actually started in automotive way back in around 1991, so I'm showing my age a little bit there. Had about 8 years in automotive and then moved into aerospace. I was always fascinated with aerospace as a kid, and I saw an opportunity, so I took it. I worked for Airbus in the UK on a number of programs, mostly in mechanical systems design on the wings of various aircraft, and became quite specialized and learned all the CAD skills and all the good engineering techniques in aerospace whilst there. And then in 2009, I made a bit of a jump and I moved to Bombardier, who were based in Montreal in Canada. Worked as a structures integrator, bringing in all the different structural elements of the fuselage of an aircraft called the C series, which ended up becoming the Airbus A220. And then, sort of systems installation as well, and how all of that attached to the fuselage. I moved into flight test for a couple of years. Flight test was the most incredible environment. I learned more in 2 years, I think, than I probably had in about 15 years in product development. It's so fast paced, you need to fix things rapidly. You've got very expensive assets sat on the ground. You've got all the safety elements, with people on board. And it's test, so you're going to discover things. So that was a fascinating experience for me. I learned a hell of a lot, worked with some incredible people. And then in 2015, I moved to Seattle in the US, and I was working for a company called Aerotech, and they focus very heavily on flight tests as a service and a lot of engineering, aerospace development work. Really cool company, also doing amazing things, got involved with a number of really fascinating programs, including some of the latest technology coming to powertrains in aerospace, hydrogen electric, battery electric, etc. So had a really great time with it, again, with amazing people doing amazing things. But I could see this whole kind of mushrooming, ballooning area of the industry, and in fact, multiple industries, getting the benefit from all these latest engineering tools, whether it's a PLM system, CAD system, simulation tools, and now with generative design and AI coming in, I just found that this was a fascinating area. I could apply my skills from one industry to multiple industries, and I ended up joining Applied CAx about 8 months ago now. So it's great to be here and excited to get this podcast launched.
Yeah, and I think, your background obviously will lend itself really well to this podcast, and also Applied's track record of working with really innovative aerospace and defense and energy companies. Can you give us the 10,000-foot view of what Applied CAx is and does?
Yeah, you bet. So Applied CAx is an approved Siemens digital industry software reseller. So we will sell Siemens software to various customers. We're a platinum partner, which means, we're a certain level of pedigree and expertise. And we've been partner of the year for North America 3 times out of the past 9 years, I believe now. So again, that speaks to the level of competence in the team and how hard we drive and how we really help customers kind of tailor solutions to their actual business use case and listen very intently to the customers. We focus mainly on 2 areas, aerospace and defense and kind of new energy, clean energy. That could be nuclear and hydrogen and things like that. There's a lot happening in that space right now. And those 2 industries are actually quite compatible with each other. They're heavily regulated for good reason. They use somewhat exotic materials. They follow very similar processes. And so there's a lot of synergy and overlap between those 2, and it's fascinating to see both of them, maturing and evolving and developing new technologies that are going to benefit all of us. So, Applied's a great company, number of really outstanding technical individuals. We've got a number of great processes internally as well. So we love helping innovative companies bring world-changing technologies to market, and we do that through selling Siemens software and associated services, adding value on top of those software tools as well.
Yeah. And, this podcast was actually your idea, and obviously because you have your finger on the pulse of what's going on in the industry. Can you just tell us a little bit about what we can expect with this podcast? What was the inspiration behind it. What was your thought process there?
Yeah. So I think we live in the most fascinating of times. We live in the exponential age. It's a time of incredible change, and you can literally see it and feel it. Yesterday, I was watching again, SpaceX launching Starship Flight Number 7, landing it between the chopsticks. Blue Origin had the New Glenn rocket launching yesterday as well. So a big day for space yesterday. And it's just something new happening every day in multiple industries, whether it's medical with, breakthroughs in gene editing and all the associated technologies, on a biotech kind of front, automotive, software-defined vehicles, autonomous vehicles, humanoid robots. There's just a lot happening. The pace of change is increasing. And I wanted to have a forum where we could discuss some of those things and then break it down into much more technical details around how some of these tools from Siemens can help and actually fuel that, kind of ever-increasing pace of change. So that was a big impetus for developing this podcast. Digital transformation is kind of at the nexus of all this next level industrialization of AI, right? So if you look at Siemens and where they're positioned, and you've got NVIDIA with the chips and obviously all the software and the foundational tools, it's a really interesting kind of combination where Siemens are in the middle of all of this and helping, again, very innovative companies do incredible things. And I want to break down some of those sometimes complex topics and go a little bit deeper, but always with a mind of bringing us back out and looking at the big picture. So here's a discrete topic, we'll go deep. And how does that fit together in the wider ecosystem, whether it's, manufacturing, engineering, new digital tools with AI, the greenification, decarbonization of the world's, energy industry and automotive and aerospace industries and things like that. So I'm hoping through this forum we can zoom in, look at the very clear benefits, look at some of the challenges as well. It's not all rosy. How do I very discreetly deploy these tools and gain the benefits? What lessons have we learned over time from various deployments? And how can I do that in my own company? So that's the overarching objective of the podcast.
Great. And I mean, we'll have plenty of time to explore both niche and very broad topics, as well as bring on a lot of experts. But can you give us an idea of what sort of topics we can expect to cover in the podcast?
Yeah, it's going to be quite varied. And I actually created a PowerPoint presentation to share and explain that with the audience because I kind of needed to figure out how to actually, explain some of this stuff myself. There's definitely a bit of a journey that we're going to go on. So I'm going to share my screen here. We're going to have a couple of formats for this podcast as well, right? So we're going to have essentially an audio only version, and then we're going to have the visual version as well where you can see the slides. So I try to describe this for those people that are just listening over audio. So we're going to start, if I discuss three major themes, right? We have what I just mentioned, we're in the middle of the exponential age. And what do I mean by that? Well, again, we're seeing increasing pace of change. And really, there's 5 major technology forces that are combining. And you'll see this on the next slide as well. But those 5 areas are energy storage, whether that's battery technology or other ways of storing energy, blockchains, genomics, robotics, and AI. And AI really is a central catalyst for a lot of these things. So looking at how all of those combine and kind of decomposing that, deconstructing it, demystifying it a little bit, and again, going deeper into certain topics is one theme that we're going to discuss. We are in the exponential age. Next is forcing functions. What's forcing and driving some of those things to actually happen? Well, you've got AI, as we mentioned. You've got energy demands that are associated to that. AI is very energy intensive. And so we're going to need more and more power very, very quickly. And obviously that power needs to be clean to make sure we don't damage the planet and damage environments and societies and things like that. So those are kind of a couple of forcing functions. You've got cloud infrastructure that's really come into its own over the last decade or so. The ability to access your data anywhere in the world on any device at any time, and it all syncs up seamlessly together. So the cloud has been a great forcing and enabling function. Decarbonization, that overall push, whether it's in automotive, aerospace, energy generation in general, all industries are looking to decarbonize. Onshoring of manufacturing, certainly to the US. The pandemic showed us that our supply chains can be fragile at times. And while sometimes it absolutely is the right thing to do to have a lower cost, point of entry for the product, sometimes, certainly if it's strategically important, maybe it makes sense to have a multi-threaded supply chain. So you have some manufacturing onshore, for example. So we're seeing a lot moving in that direction. I also feel like we're in the middle of a manufacturing super cycle. The tools and techniques for how we're manufacturing things ever quicker, ever more customized, is really showing us that, you have to bring these tools to bear, whether it's 3D printing, whether it's a lot of the technology around NC programming and inspection. And so all of those things are also kind of forcing things to be faster, or certainly enabling them at least. And just an increase in digitalization and customization. I remember the time I bought my first mountain bike. I had about 6 or 8 to choose from. Again, it was a long time ago. I'm showing my age. Nowadays, I mean, the choice is bewildering, and it's fantastic because you can get it completely tailored to your own needs. Yesterday, I bought my son his first set of skis. He's finally stopped growing. And, we were there with the guys in the store. And I mean, the amount of choice again on the boots alone and how you can tailor the fit, get your foot heat molded inside it, adjust the angle of your foot inside, adjust the different pain points around the foot. I mean, it's like having a bespoke, tailor-fitted ski boot. So the amount of customization, whether it's for a certain mission, a certain product type, a certain environment, has increased for good reason. And I think that's going to continue to increase. So again, these are all forcing functions that are sort of driving us into this exponential age. And then the last broad theme are the enablers. Some of the things that are enabling this, the amount of compute, the power, the throughput, the massive data centers that are being threaded together nowadays, that's enabling a lot of this. The digital twin, threading that information seamlessly so there's no friction in the system when I go from requirements to simulation to detailed design into releasing the part for manufacture, program it, inspecting it, assembling it, installing it. All of that information threaded together in a singular environment is enabling, this speed of transformation and increased digitization. The digital twin, having a digital version of the real life version and then mapping those, overlaying those on top of each other and understanding how the real world product is behaving and then modifying or simulating different settings, different parameters on the digital side to see the impact on the real side and then pushing those changes through. So that's also a great enabling function. You got things like the industrial metaverse where we're able to simulate to a very, very high level of fidelity now, almost movie quality, whether it's, an industrial plant, an ocean-going ship, an aircraft, with photorealistic graphics. And as it's all going into AR and VR, there's just a lot happening in the industrial metaverse space as well, which is enabling teams to collaborate much more quickly and easily. And just overall, the direction that Siemens are taking, industrial AI, infusing large language models and AI generative design into some of the tools, those are also enablers. So we're going to explore all of those broad themes. And then from there, we're going to drill down a little bit. We're going to have a deep dive into the aerospace and defense industry. How are those techniques, tactics, tools being deployed into aerospace and defense? And then separately, we'll have another deep dive into the new energy sector. What's happening there. And then from there, we'll go a bit further down again. What industry challenges do we see in aerospace and defense? We'll have some case studies. We'll look at the new energy side. We'll talk about fusion, fission, and again, some case studies. And then we're going to drill down even deeper after that. So for example, for both industries, we're going to talk about Team Center. What is Team Center? What does it do? How do I get the most out of it? And within that, there are various modules: change management, requirements management, integrated project planning and execution. Then we have on the design side, we have things like NX as a CAD system, FiberSim for composites, Capital for electrical systems, Mendex, which is a low-code application development platform, and how you can build bespoke tools within the systems to, extract data, reformat it, repurpose it, and do all manner of things that are really powerful. We'll talk about methodologies. Model-based systems engineering is one particular methodology that's really, really powerful. So we'll dive into that. Model-based design and parts manufacturing information, MBD, PMI. How do we eliminate 2D drawings? We live in a 3D digital world. So why are we still converting that 3D information into 2D drawings so somebody can read it somewhere, when nowadays We have all of the tools at our availability. We have 3D PDFs where if you have a tablet, you can literally open up Adobe and you can spin the model and interrogate it to a certain extent with your fingers and, go ahead and make that part per spec. And then the digital thread, what does the digital thread actually mean in practice, and how can you, increase your penetration into the digital thread? Then we'll look at AI. Where is the state of AI today in engineering? What does generative design mean? And how can we convert some of these new technologies into specific applications where we're leveraging AI and machine learning to deliver certain products or certain ways of working within these systems? And then lastly, kind of wrapping it all up again, visioneering, right? Where is all of this going? What does it mean from an optimization perspective? What will the company of the future look like? There's a term out there called platform as a service. What does that mean? We'll have a whole episode on that. And then what does this whole world look like in 10 years from now? 2035, what will engineering, manufacturing, servicing, reliability and all those sorts of things look like in 2035? So I think we've got some really interesting discussions to have around that. So that's a summary of where we're going overall. Some very broad themes, and then we'll go deep into certain topics. And I think one other thing just to mention, one last slide here. Again, I mentioned it earlier, but we are at a really interesting point in history. And those 5 technologies that I mentioned are converging. And there's a theory out there. This is research that's published by ARK Invest, the great company that looks at the impact of new technology that's coming to bear. And they are predicting that over the next 10 years or so, 3 times the market cap of the internet will be generated by these 5 technologies combining. And this is an absolutely unprecedented time in history. The only thing that's remotely comparable is when we had the internal combustion engine, electricity, and the telephone, kind of around those sorts of time frames combining at the same time. And we saw a massive boom in wealth and, societal overall well-being. And we're on the cusp of something even larger than that now, with AI as the core of it, but all these other industries are going to benefit. So I thought it was a really interesting slide to frame up in this first episode, just to show where we're currently at and the impact of some of these things as we go forwards.
Awesome. Yeah, I mean, there's going to be something for everyone. And the good news is the news keeps coming. So I don't think we'll ever run out of topics. We also promised to bring on experts in the fields that we're talking about. Our next several episodes will be with Mark Sampson, who is our MBSC evangelist. And he is very knowledgeable in systems engineering, and we are so lucky to get to work with him. And he'll be here for a few episodes after this, but we hope that you can join, and we hope you find that informative, and we can't wait to talk to you next time.
Great. Thanks, Cheyenne.
Thanks.